In this video, we will learn how to invoke VCS and Verdi to write and simulate a simple full adder program. We use Xming with PuTTY SSH client. Xming allows the Windows machines to display a graphical Linux program which is basically running on a remote Linux server. Now open the PuTTY session configuration window by double-clicking on putty.exe. In the session category, specify a host name or IP address you want to connect to. Now select connections followed by SSH followed by X11 and make sure that the enable X11 forwarding box is checked. Once we log in, we are now ready to write and simulate the full adder program. So we start by creating a directory, full adder, using the mkdir command. The next step is to create the Verilog files and the testbench files inside this directory. So now we use the vi command to create a file fulladder.v. Press I on the keyboard to enter the insert mode and type the Verilog code for the full adder as shown here. Press escape to come out of the insert mode and type :wq to save and exit. Similarly, create another file fulladder_testbench and type in the testbench for the full adder module. Make sure to include the fulladder.v file in the testbench file by using the tick include statement. Make sure to write the $fsdb dumpwares command inside the initial block. An FSDB file is a flat ASCII file used for storing the simulation waveform data. This file will be later imported to Verdi to display the simulation waveforms. Now open the bash rc file using the v command as shown. Now make sure set novas_home and export novas_ statements are present in this file. If these two lines are not present in the bash rc file, then add these two lines to this file and save the file. Now source the bash rc file to apply the changes made. Next we invoke VCS using the command shown. Full64 debug access plus all LCA and KDB are the switches used here. This command compiles the Verilog code fulladder_tb.v. Make sure there are 0 errors and warnings. We use ls command at each step to see what files are generated in the directory after running the commands. We now invoke Verdi simulator using the .simv Verdi command. Now make sure that novas.fsdb file is generated in the directory. Now we invoke the Verdi simulator using the Verdi command as shown. This opens the simulator GUI where we can see the waveforms. It takes some time to open the GUI. Now go to File, Import Design and add the fulladder_tb file. In the program, we can see all the ports highlighted in red. So right-click on any one of the ports and add to the waveform. Here we added the port A to the waveform so we can see the waveform for the signal A. Similarly, we can select all the ports and add to the same waveform. Now you can see the waveform for the full adder and check for the correctness.